Hello again. That was a long FRQ, so I'm gonna jump to some of the shorter problems for a little bit. Okay. So, blast from the past, unit 4, looking at some binomial probability. Don't freak out. According to a recent survey, 81% of adults in a certain state have graduated from high school. If 15 adults from the state are selected at random, what is the probability that 5 of them have not graduated from high school? So 5 of them have not graduated from high school. So that would be a 19% probability. So 81 and 19 makes 100. Okay. So this is very typical of the College Board, just the setup. They're not asking you to calculate the probability. I am in a second. But first, we just want to get the setup down. So first up, we have 15 total, and we're looking for choosing 5 of them. So this first bracket represents the number of ways to choose a set of the bottom number out of the top number. So since we have 15 adults and we're choosing 5, we can cross out anything that's not that. This is 20 adults choosing 15. That's not what we're looking for. This is 10 adults choosing 5. Also not what we're looking for. This is out for the same reason. So right there, we're narrowed down to 2 just because we know it's 15 adults and we're choosing 5 of them that have not graduated. Okay. Then these exponents need to add to 15, and in both cases they do. So we need to figure out what the difference is. This one has the 19% being raised to the 5th power and the 81% being raised to the 10th. This one is the 81% being raised to the 5th power and the 19% to the 10th. So 81% have graduated from high school. They have graduated from high school. But then we want to know that 5 of them have not graduated. So if 5 of them have not graduated, there's a 19% chance of that happening, and it needs to happen 5 times. Out of 15, that also means 10 of them have graduated, and that needs to be our exponent on the probability that they have graduated. So this is going to be our answer because the 19% happens 5 times, raised to the 5th power, and the 81% happens 10 times, which is what we're looking for based on the context of this question. Now, what is the probability that 5 of them, so exactly 5, this is a binomial PDF situation. So we're going to use our calculator, and we're going to say binomial PDF. P because it's exactly. This question didn't say at least 5 or more than 5. And part of the reason it doesn't say that is when you're doing this by hand, you'd have to do this for each iteration and then add it all up. It's very tedious, and even the College Board doesn't want to print that out. So binomial PDF, so we go into our VARs menu. It's option A. There are 15 adults, so that's our number of trials. The probability that we're looking for, is 5 of them that have not graduated. So we're going to use the 0.19 because that's the probability of what we're interested in. And then the X value is the number that we're interested in. So that 0.19 has to happen 5 times. All right. When we do that, we get a probability of about 0.0904, or about 9%. And that makes sense. This is way more than, let me rephrase that. This is way less than 20%. It's, 33 1/3%. So we're going to expect that to have a kind of low probability. That's a lot more not high school graduates than we would expect from a pool where 81% do graduate high school. Okay, onward. So this question, a police officer uses a motion detector to indicate whether a car is traveling faster than the speed limit, aka speeding. Don't speed, it's really not safe. A speeding ticket will be issued to the driver of the car if the officer believes the driver is speeding as indicated by the detector. This situation is similar to using a null and an alternative hypothesis to decide whether to issue a ticket. The hypotheses can be stated as follows. So the null is that the driver is not speeding, and the alternative hypothesis is the driver is speeding. Which of the following best describes the power of the test? So just a little reminder, power is the probability of correctly rejecting the null hypothesis. So power is the probability of correctly rejecting the null hypothesis. Okay, so we want to reject that. The driver is not speeding. Let's look at our answer choices. So A says the probability of issuing a ticket to a driver who is speeding. So issuing a ticket means that we landed on the driver is speeding because we're giving them a ticket. And then, so issuing a ticket is rejecting the null to a driver who is speeding. They are speeding, so we correctly rejected the null. This is going to be our answer, but let's just take a peek at the rest of them. So the probability of issuing a ticket, so that's rejecting the null, to a driver who is not speeding. So that's falsely rejecting the null. That's our type 1 error. So that's not the power. The probability of not issuing a ticket, so that's failing to reject the null, who is speeding. So that is, we should have rejected the null, but we didn't. It was just one of those edge cases. This is our type 2 error. Also know what we're looking for. Probability of not issuing a ticket, so we're not rejecting the null, to a driver who is not speeding. So the null isn't actually happening. Or excuse me, the null is actually happening because they're not speeding. Yeah, so that's our true but boring situation. And then the probability that the motion detector is working correctly. So that isn't going to be the power of this test as set forth by the hypotheses. The motion detector working correctly is a good question, but it's not the one we've set up with our hypotheses. So we can't say anything about that right now. All right, onward and upward. Why did I pick such wordy questions? They're wordy. The mayor of a large city will run for governor if he believes that more than 30% of the voters in the state already support him. He will have a survey firm ask a random sample of N voters whether or not they support him. He will use a large sample test for proportions to test the null hypothesis that the proportion of all voters who support him is 30% or less against the alternative that the percentage is higher than 30%. Suppose that 35% of the vote of all voters in the state actually support him. In which of the following situations would the power for this test be the highest? Okay, so power increases with sample size. Power also increases with the significance level, because the power is the probability of correctly rejecting the null hypothesis. So sample size just makes our curve narrower. So that's a bigger or a smaller sample size. This would be that same with a bigger sample size. So it just, this outward case is less likely in the blue with a bigger sample size. So you're more likely to reject the null, therefore giving it more power. So as power goes up, the sample size should go up, the alpha, but all of those things will make power increase. This is also the probability of a type 1 error increasing, but sometimes we're okay with that. So first, let's look at sample sizes. So Mary's is significance level. I'm going to ignore that for a second and just look at the ends. So 500 voters is definitely going to have more power than 250. 1,000 voters is going to have more power than 500. Same logic, 1,000, sample size of 1,000 is going to have more power than 500. And now we're down to 2 options. And remember, if you're down to 2 options, 50-50 chance of guessing correctly. If you got every single multiple choice on this test down to a 50-50, you'd get 20 out of 40 points on the multiple choice, which is actually putting you in a pretty good position. All right, so that was our sample size. We checked that. Now let's look at our significance level. First significance level is 0.01. This one is 0.05. Well, we want the higher significance level as well. There we go. All right. Number 8. After a tropical storm in a certain state, news reports indicate that 19% of households in the state lost power during the storm. A state engineer believes that estimate is too low. The engineer will collect data to perform a hypothesis test on the proportion of all households without power. Which of the following are appropriate hypotheses for such a test? So, first and foremost, hypotheses never have hats. Go away, tiny hats. Go away, tiny hats. It's a good card in a game, a falcon with a tiny hat or a falcon with a tiny cap. Okay, but not in our hypotheses. Then, the state engineer believes that the estimate is too low. If he believes that this 19% estimate is too low, he thinks the actual proportion is higher. So all of our null hypotheses are the same. We need to find the alternative hypothesis that says we actually think the proportion is higher than 19%. This is a less than, it's pointing to the left, so less than. That's not higher than 19. This is not equal, which it could be our more conservative position, right? A two-tailed test is just a more conservative position, but the hypotheses that best match this situation are these, because the state or the news report says that it's 19%. The state engineer thinks it's higher, that it's more than 19%. That's it. Alrighty. Number 9. A scientist recorded the duration of eruptions of Old Faithful Geyser in Yellowstone National Park that occurred during a 1-month time period. The histogram below shows the distribution of the duration in seconds of the eruptions. Completely describe the distribution. If you see the word describe, you should immediately think about cussing. So, C-U-S-S. And we are going to BS our way through this. We're going to be specific. So, the center is, we've got this nice bimodal distribution, which we'll add to our shape in a moment here. And I would say the center, based on just more of our data being here, is probably in the 200 to 225 seconds. It's not about the number of eruptions. It's about the X. These are our counts. This is what we're talking about. So the center is center, and I'm even just going to say the median is around 200 to 225 seconds in duration. And notice, I'm not just saying it's around 200 to 225. I'm adding the seconds because there's our context. When you're describing, if you don't include the context, what you're saying doesn't mean much and you'll lose points. For the short term, losing points is important. Long term, not having like meaning to what you're doing is important. Okay, unusuals. I don't see anything that's going to look like a gap or an outlier. So I'm going to say no apparent gaps or outliers, right? Maybe we'll end up with some outliers over here, but probably not. And there are no gaps because everything has at least some data in it. Even if it's a tiny little bit, there's something there. Shape. Well, this is a bimodal. And like it's almost symmetric, but not quite. So I'm just going to leave it at a bimodal distribution. And for spread, without the actual data, we do not have enough specificity in our data. We don't have these actual heights. We don't have these actual numbers. We can't really get an IQR or a standard deviation. So the best we can do is range. So we're going to say duration, and this is for our spread. The duration ranges from 75 seconds to about 325 seconds, right? We should probably say about on both of those. We don't know that it exactly is at 75 or 325. Those could be just, the most convenient cutoff. So these aren't crazy numbers. And remember to be careful. We can say that it ranges from about this to this, or we can say the range is and give a single number. We would never say the range is 75 to 325 seconds. That would be incorrect. Okay. Sweet. Number 10. 2 large containers, X and Y, contain many colored beads. From a random sample of beads taken from container X, the proportion of blue beads in the sample was recorded as p hat sub X is 0.35. So about 35% blue beads in sample X. From a random sample of beads taken from container Y, the proportion of blue beads in the sample was recorded as the proportion of blue in container Y is about 0.39, 39%. Assuming all conditions for inference are met, which procedure, so that's what they're asking here, which procedure is the most appropriate for estimating the difference between the proportions of all blue beads in the containers? So this is 2 sample because we have 2 samples. It actually states a random sample and a random sample. We have 2 separate samples. So this is a 2 sample, or if you want to think about it as a 2 prop. And then it's a test for the difference. I need more space. 2 sample test for the difference in population proportions. Or a 2 prop Z test for difference in population proportions. This is going to be the thing that catches you. They will always give you the right this with the words sample proportions here. Sample proportions is never what you're testing for. You don't need to perform a test and estimate that. You have your sample proportions. The difference here is 0.04 or 4%. We don't need to run any tests for that. we're using the samples to make conclusions about a population. So that's why it's always for population information. All right. And for 11, last but not least, for this little chunk, a survey was conducted to determine what percentage of college seniors would have chosen to attend a different college if they had known then what they know now. Ooh. Live your life with no regrets. And a random sample of 600 seniors, so random sample, 600 seniors, 34% indicated that they would have attended a different college. Create a 90% confidence interval for the number of seniors who would say they would attend a different college at a college with 1,960 seniors. Okay. We're going to go straight to our calculator to create the interval, because what I want you to focus on here is our interval is going to be about the proportion. And then we need to shift it to answer the actual question being asked. So this is a one sample or one prop Z interval. We have 34%, so one prop Z interval. X is going to be 0.34 times 600. And that happens to come out to exactly 204. That must be a whole number. So if that had come out to anything with the decimal, just round it to the nearest whole number. So that's our X. Our N is 600 because that's the number sampled. And our C level is 0.9. Nope. There we go. Our C level, our confidence level is 0.9 because that's 90%. 90% confidence. Okay. So we're going to calculate that. And we get our interval to be from about 0.30819 to 0.37181. Again, I am skipping all of the, if this were an FRQ and you were doing a confidence interval, you can see some of the other questions for going through that process more methodically. I just want to get to these numbers. The key here is these are the proportions. So we think anywhere from about 31% to about 37% would say they would have attended a different college. We want to know the number of seniors. It's not asking for the proportion. We want to know the number. Since this college in question has 1,960 seniors, we are going to get that interval by multiplying this by 1960 and multiplying the other end of our proportion interval by 1960. So 0.30819 times 1960, and I'm just not even rounding here, is 604.05. So I'm going to say 604 to 0.37181 times 1960. 728.7. So I'm going to say about 729. So this is the correct interval for the answer to the question because it is about the number of seniors. This interval correctly gives us the proportions we're interested in, but it would not be the correct answer to this question. We have to put it in terms of the number of seniors. Okay, gonna take a little break. Be back soon. Hope this was helpful.